Welcome to the second video of the series. In this lesson, we will learn how to organize the game entities and how to create a map for the game. We will continue where we left off on the last lesson, and like before, the source code will be available through a link on the video description. Before creating the map, we will define a class that will describe basic properties and operations for all the entities on the game. We will call this class GameEntity. It will be an abstract class that will serve as a common ancestor for actors in the game. We need to define two basic properties needed for a game object to be displayed: a position and a mesh. The position will determine where this object is placed in our scene. The mesh will be a general container for geometry, materials, or in some cases, other child meshes or objects. We will create a getter for the mesh and set the position on the constructor. Besides keeping the position as a reference, we also need to set it on the mesh. Otherwise, all meshes would appear on the center of the scene. As for behaviors or functions, we will define two: load and update. The load method will be used to bring textures, models, and other assets into the game. The update function is where we will be moving, rotating, or transforming the object. Since every object in our game should extend from this class, we can now create a list of entities in our game scene object. We will now see how to implement the load function on the objects of the array. Although right now it's empty, this will change soon. The way we will do it is simple. We iterate through the array and call the load function. It doesn't matter if it is the map, walls, or our player. As long as they are inheriting from this class, we can call this method. After the element has been loaded, we need to add it to the scene. Since we will be using Three.js as sync methods to load resources, we have to make our load method asynchronous as well. The way we will use this class is via inheritance. In other words, when we define an object that requires this behavior, we will make it a child class of GameEntity. We will see how to achieve this by building the map object, which we indicate to extend from the GameEntity. At this point, our GameMap class already has all the base properties and behaviors. Because the GameEntity class is expecting a position on its constructor, we have to do the same on the objects extending from it. We pass this parameter to the base class by calling super on the constructor. You can think of the map as a chessboard. It will be a collection of square tiles. The size property will define how many rows and columns the map will have. To simplify things, we will create a helper class for each tile. And since each tile requires a position and a mesh, we can extend from GameEntity. We will implement the load behavior, which in this case will be creating the geometry for the tile and assigning a material to it. For the material, I have included a few textures that are also included on the source code as well. All the credits are in the video description. We use the texture loader object from Three to load the textures into the game. The plane geometry is perfect for this case. We will define its width and height to one map unit. To assign the texture, we create a mesh standard material and we set the map option to the texture. It is time to create the mesh that will appear on the game. In this case, we will override the base property. Just remember that every time we create a new mesh, the position needs to be set to the correct one. Otherwise, it will be on the center of the scene. Now that we have defined a single tile, we will update the map object to contain a collection of these. As I mentioned before, the map resembles a chessboard. To create this structure, we use two nested for loops. The only parameter the tiles are expecting is their position, which, since we have defined them to be one map unit in size, we can use the loop iterators. Finally, we need to load each tile. We will do it by overriding the load method on the map object. The concept is simple. We go through each tile and load its geometry and texture. After it has been loaded, we have to add it to the map mesh. Remember, the game scene will add this mesh to the scene after calling the load on this object. It is time to see our map in action. On the game scene constructor, we will create the map on the center of the scene and we will set its size so it's 15 rows and columns. Because the game map extends from game entity, all we need to do now is add it to the list of entities. If we run the code, we should see a cutout black shape that doesn't look like the map or like the texture we used. Although it seems we have done something wrong, we have not. We are just seeing the tiles from way too close and without any light. The first thing to do is to add a light. I've chosen the hemisphere light because it's a global light that affects all the entities. We can now see the texture, although we're still too close to it. If we zoom out, we can see the map was created on the center of the scene. If we move the camera to position on the center of the map, we should have a better picture of it. Before finishing the lesson, I would like to improve a bit on how we load the map. Right now, we are loading the same texture every time we create a tile, and this is not a very efficient practice. We will create a class called Resource Manager. Here, we will do the loading of textures and assets, and we will store them. As before, we will implement a singleton pattern, since only one instance is required. For now, the class will store some textures for the map. The load function will be an entry point. Internally, we can create more functions to load different assets for the game. Instead of creating a texture loader for each texture, we can create one instance to be later used as a parameter for other functions. We will now create a function to load the map textures. This method will make use of the texture loader we created before. I have created an array, but you can load the textures individually. The idea is for you to imagine the list of assets being retrieved from a config file. Now that we have the method ready, we can call it from the main load function. To test everything, we are going to create a function that returns a random texture for the map. Before updating how tiles load their textures, we have to call the Resource Manager load function on the game scene. Tiles will no longer load textures. Instead, they will request a random one from the Resource Manager. Now, besides having a more interesting map, we have greatly improved performance. This is all for this lesson. We created our base class for the elements on the game and we apply it for the map. We also learned how to improve performance and isolate loading assets in the game. I hope to see you in the next class, and thanks for watching.